Hello guys, welcome back to Constant GIS. So today you're going to do land surface temperature, and on my screen you can see a roadmap that you're going to follow. So this roadmap has 4 steps, if not 5. The first one is conversion of top of atmosphere radiance. This will use band 10 to calculate that, and you can see the formula. So I'm going to show you some of the tricks and how these values come across these values and where you can find these values as well. The second step is conversion of the top atmosphere radiance brightness temperature. Same, I'll show you the formula and where to find the values of these and how you can actually copy paste these values to your ArcGIS, and then you can do the run. You can run the calculator. The third is the NDVI. We use the band 4 and band 5. And then the fourth is the land surface emissivity. And then finally, we will do the LST. So with that said, we need to have 3 bands, which is band 10, band 5, and band 4, which is the case in my case. I've loaded band 4, 5, and 10, and I also have my area of interest here. So the first thing you need to do is calculate the top of atmosphere radiance for band 10. In this case, you're going to use band 10, and as the formula states, it's ML, which is the radiance multiplicative band, multiplied by the QCAL. This is the quantized and calibrated standard product pixel value. In this case, is the band 10. You can see, and then the AL, the radiance add band, and then the OI, which is the corrected value, which is 0.29. So that said, this ML, which is the radiance multiplicative band, and the radiance add band, they can be found when you download the Landsat itself. So if you can see in my Landsat, there is this .tx file, which if you open it and you scroll down, you can see I have the radiance add band for band 10, which is 0.1, and that's the case. That's the case here. And same for the radiance multiplicative band. You can come the radiance multiplicative band for band 10 is this one. So that said, that's how these values have been come across. You can always check with your file that you downloaded from USGS and see if these values are the same. But in my case, I've done it for more than one area, and I've found out that they are actually they are the same, not almost, they are the same. So that's for the top of atmosphere. So for the brightness temperature, you can see I have K2, which in this K2 is the K2 constant band. Same for K1. For TOA is what you'll have found from the previous analysis. So I just want to show you where we can find the K1 and K2. Same in this file. If you scroll down, you will see K1 for band 10 and K2 for band 10. So you can see 1321, that's K2. Which is the case in this guy, and then the K1, which is 774. So these are the 4 values that you'll need to extract from this file. Otherwise, the rest will be using what we'll have done previously. So that said, I want to say one more thing: the naming convention, so that we can just adapt these already established formulas and the values that you have already set in this file. We will maintain this naming convention. For example, for the top of atmosphere, we'll use TOA in caps, uppercase. Same for these, we'll use BT, so that if you use this formula, we can just adapt the previous file that we saved as TOA. So same, you can see I've used BT, and then in the next case where we'll be needing the BT, it will be much easier for us to use. Even you can see BT is being used when calculating the LST and etc. So that said, we can jump into the analysis and do the top of atmosphere radiance. So the first thing I'm going to do, just going to copy these. I will share this file in the video description so that you can get started. So I've just copied that, and I'm here. You can see I've also renamed the bands. This is very important because the bands don't come as band 4, 5 like that. So you will need to rename the files as well to match the naming convention. So that said, we will go to the Arc toolbox, and then I'm going to open the spatial analysis tool, and under map algebra, I'll use the raster calculator. This is what we'll be using the whole time, the raster calculator. So that said, you can paste your formula, and then I'm just going to name these as I'm just going to name this tower. So I'm just going to change my database. I'm just going to name this tower. Okay, so it's saying there's an issue. It's just, you can just delete the band 10 and then add it, double click on it. That solves that, and then just click run. So you can see it's already running. So that's for the top of atmosphere reflectance. So that said, we can always, I can just go there and copy the next one for the brightness temperature. And these are the values. You can see I'm adapting the tower. That's why I named the previous file as tower. Coming back, you can see it as done running. So I can just get rid of band 10. I don't need it anymore. So I'm just going to go back to raster calculator, and this time I'm going to calculate the brightness temperature. Just going to copy the formula. You can see I'm adapting tower because I already have it top here, and I'm going to save this as BT. Remember, these naming conventions are very important for formulas. BT. Maybe for this issue, I can just remove add these afresh. You can just delete the tower and then double click on it. That should solve the issue, and then just click run. So with this, we're going to generate the brightness temperature of these band 10. So the third step as it runs is we are going to do the NDVI, and for NDVI it's band 5 minus band 4 divided by band 5 plus band 4. So once this is done, which in my case it's done as well, it has run successfully, I can just open the raster calculator again. So for NDVI, you have to start with float because we're dealing with decimal points, which is band 5 minus band 4. And then I'm going to divide by these, float again, band 5 plus band 4. So I'm going to save this as NDVI, save it in lowercase, save that, and then run. So I'm saving it in lowercase because if you look at my next, when we are going to calculate the land surface emissivity, we are using NDVI. And in this case, you can see I've already had the formula here because I'm doing NDVI minus the NDVI minimum value divided by NDVI max value minus the NDVI minimum value. So I've done this before, and these are the values I found. So I'm just going to copy these, and I'm going to show you how you use the square. So it has done running. You can see I have my NDVI as well as the topmost layer. So I'm just going to come back here, and I'm going to calculate here I'm calculating the proportion of vegetation. This means the vegetation that is covering the area of study, or rather the image itself. What percentage of the area is covered by vegetation, and one that is not covered by vegetation. And then we'll use the PV to calculate the emissivity value for our Landsat. So going back to ArcGIS, raster calculator, I'm just going to paste the formula. So you can see I'm using square. You can get square from here. And then the NDVI is this value. This is the minimum value, the NDVI mean. So the NDVI mean is this value, the low value. And I'm using plus because it's NDVI minus an NDVI mean. And in this case, it's NDVI plus, it will be minus. Well, in math, it's minus is addition. This is what is happening here, and this is the same thing happening in this case. So that said, I'm going to save this as PV in uppercase, and I'm going to save this, and I'm just going to run this. So sorry, I'm getting an issue. So I'm just going to delete the NDVI, and I'm just going to add it fresh. That said, I can run it now. So it's going to calculate the PV, that's the proportion of vegetation. And once that is done, we will calculate now the emissivity. Where E is land surface emissivity, P is the proportion of vegetation, as we have said. And you can see we have a corresponding value for the value of the equation. So I'm just going to copy these. I can see it's done running. So to calculate the emissivity, double click again on raster calculator and just enter the paste that. So we have, you can always delete these and just add it afresh like that. Then I'm going to save these as E uppercase. Remember, this naming convention is very important, and I'm going to run these. So we will have calculated the land surface emissivity, and finally we can now do the land surface temperature. This is done using this formula, and we are going to use the brightness temperature we did earlier before, and we're also going to use the emissivity value that we did just now. So you can see for these we have some constants like the C2. This is done running. So for this you have the C2, which is 14,388. These are some of the values, and you can see I've already sorted this equation. Just going to copy these. Let me just copy these and open the raster calculator, and now we are calculating the land surface temperature. Whatever output gets out of this is the land surface temperature. So the output, I can save it as the LST and click save. So it's always good to just retype these, just delete these and search for your BT. Same for this BT. And finally for the E. And then that's it, just press run. So it's going to run again, and the final output is the land surface temperature. This is what we are interested in, and then with that we can visualize it using maybe reds and greens colorum, and see where we have high values of surface LST and low values of LST. So it's done running, and we can just switch off everything else and just remain with the LST itself. So even these bands, we no longer need any of these. So that's it. You can see we have all these. So, but before we go ahead, I'd like to clip it to my area of interest and then visualize it. So for that, since we are clipping some raster data, I can go to search and search clip. So it's data management. So for my input raster is the LST. Output extent is Kiambu. It's a county in Kenya. Yeah, its neighbors are Nairobi City. And then I'll check this to ensure that it actually takes the boundary, the exact bounds of Kiambu. And I'm going to go call these, let me just say clipped. Save that, and I'm going to run. So it should extract the bounds within these, and then we can just visualize with a better colorum. So that done, I can just now remove the LST and maybe the boundary. I don't need it anymore. I can zoom this to layer so that it can take most of the screen, and then I can right click on this, go to properties, and then can choose a colorum. Now you can see the highest value is 71 and the lowest is 49. So I can just come and look for greens and reds, something of this sort. Now green represents low values, and red represents areas that have very high land as a surface temperature. I'm going to apply on these, and I'm going to click OK. And you can see, guys, we have successfully visualized the land surface temperature, high values of 71 for my area of interest, and you can see today this is southwest. You can see very high values of LST, same to the eastern part of this county. So that's it, guys. You've successfully visualized our LST. You should try this out and let me know how this goes. For the Word document, it will be in the description below. Be sure to check it out. And if you have any question, you can always leave it in the comment section below. Like this video, subscribe to our channel, and see you later. Thank you, guys.